Hello guys, it's Boris here. Today I want to talk about equals and HashCode methods in Java. This interview question which you need to tackle 100%. So why we need them or why we don't need them? The answer is when we are dealing with data structures like map or set hashing data structures, we need to implement these methods because they're these structures working with those methods. And also for equality, we need to override both of the methods. I will explain why. So let's create one class. For example, the class person. Okay. And let's say this person have a name and this person have an age. Let's keep it pretty simple. Let's generate getters and setters here. And one constructor. So we have this person class with two fields. And for example, let's create person one. Okay, which is John. And it's 20 years old. And we have again John, which is also 20 years old, right? Now if we call the equals method on those two objects, okay, the equal method, you can see it's coming from the object class, which is the base class of Java. All classes inherit object class from the object class, but you will not see here extends object, okay, but it is there. You can imagine it is there. So let's see now. We expect those 12 objects to be equal, right? If we have business logic, they should be equal. Sorry. Let me run it again. I just stepped through those steps. Okay, we initialize both the objects. Now we ask if we person2 equals person1 equals person2, and the answer is false. It doesn't equal the second object. But why? Because now the equals method just try to does the equality on those reference values here, and p1 is not equals to p2. You can see here the default implementation is we pass an object, and this is the first object we compare with the second object, and we compare it with the equals operator. That's the same like if I do this here. If p1 equals p2, it's the equivalent of the equal method when we don't override it. See here, this is the first object. We go compare on it. Like, let me be very clear about this. When we say p1 dot operator, okay, equals, we mean this dot object equals, okay, in our case this is p1 and the second object is p2, okay. I just wanted to be very clear. So we are comparing the object references in the memory and not the actual values of the objects. So to fix this, let's let our ID to generate equals and HashCode. And now I will break it down in a second, but the implementation of those methods, but let's see now the effect, what it will be. Okay, we step through again. Okay, now voila, p1 is equal p2. In real life we want this result. We don't want to compare the reference of the objects, but we want to compare the values. And let's break down this equals method, the default implementation from the IntelliJ, which it provides. So it says if the current object we are in, this keyword, equals the coming object, return true. So we say if they're both referring to each other, return true directly. We don't need to compare other values. What I mean is, if we say here p1 reference equal p2 reference, okay, and we go into this method, the algorithm equals method, and we enter debug mode, and we step into it, we see this. The first one is true. Where is the breakpoint? If this equals the object, because this is the reference 775 and the other object reference is again 775. What is this means? This means we have one object of type person in the memory, and we have two reference to it. So now this check here is saying if this p1 equals this p2, and if we go back here, you can see I said here let p1 equal p2, okay, and this is it. Both p1 and p2 refer to this object in the memory. So this is the first check of the equal method. So for performance, we first check this, if the both of the references are equal. Then if not, what will happen? We check if the coming object is null or the current class is different than the object class, return false. So if the coming object is no, return from here false, or if you can imagine this is this get class, okay, and this is the class type person. If the incoming object is not of type person, for example, it's of type ship or some other class, it will return false directly. What I mean by this, if we pass here, let's remove this line. If we have some other object, let's say sheep, okay, and if sheep equal to p2, okay, it cannot, we cannot do this, sorry. We have sheep class and we try to execute this equal here, see what will happen. I can go through the debugger. Okay, on the second line, this object is sheep, so it's different than this class because this dot get class is of person type, okay. Here we can omit this keyword, but imagine it is there, and we return false here, and you can see it's false. And the other scenario is if we pass just no here, the no keyword, it will return false again. So in an interview they can ask you, okay, you have implemented equivalent hash code, but what are those checks? And you should know what they are doing line by line. Or they can say you can't use auto generation from the IDE, generate the method yourself. And those came first for performance reasons. Then because after these checks, if they are true, we will gonna see if the fields are equal to each other from the first and the second object. In our case, first we are sure the both classes are equal, so we can cast the person. We can create a reference from the object we are making equality for, and we are sure this class will pass for sure because of this check, okay, and this will not fail ever. And then this one liner here says if this is true and this is true, return true. So if the age, you can imagine here again, this is the first object and there are these keywords here, this age equals the second object here, we compare the first object with it, equal the second object age, and here we are using the objects equal static method, okay. Here you can see the logic is it compares again this name from the current object with the second object name. So because of this, we now have comparing if this object, first we compare if this class is of this class type. If not, return false. We compare if this is not now the incoming object for comparison, and then we start checking field by field. Is this field is equal to this field? And is this field is equal to this field? If we had more fields, we should put them. It is okay to put them here. So why we use object equals here? Because this is a primitive type, and it's an integer, and we can use the equals operator here. And here we are comparing an object, because string is object in Java, and the IntelliJ IDEA wants to use this equals method to compare the two string, because again, if we use this, we will not compare the string literal, but we will compare the references, and it's not correct. So yeah, we can use this, or we can use this name dot equals person dot name, and this is the same thing. This is the same thing right now. Okay, so if we run this again, okay, they are equal. If you want to see the equal method in the debug mode, okay, let's see. Even we can make this with if else's, because for some of you it can be hard to read, but it's saying yes, exactly this. If this is the case, return true, and if it's not, just return false. Okay, it's the same thing, so let's put it in debug. Because the one RC are hard to read for beginners. See, now all conditions are true. The age from the first object equals the age from the second object, and the name John is equaling the second object name John. Okay, and we are in the case when there is true. We are returning true, and if we say now here the name is Jane, okay, one of the conditions will fail. See now, the second condition is false. The age are the same, but the names are not. So we are going to the false condition. So this is for the quality. We need them, but are we calling this hash code? What do you think? It's doing the hash function over these two fields, name and age. And what do you think will happen now? Will we call hash code? I think no, we will not call it. Okay, because but we don't use it, but either we implement both of these, or we don't implement either of them. This is a rule, because if we put this in a hash set or hash map, we will have a trouble, and it's unwritten good practice to this to be done, to be overridden, these two methods to be overridden together. So we solved our first problem. I have edited a bit this method to be more readable for you. So now what problem we can have in a hash set, for example. Let's define one hash set with the type person in it. Okay. we have set, we have two Johns with the same age. We add both of them. Okay. We add both of them and we want to see. Okay, let's implement toString also for dumping our result. Okay, and let's go. Okay, we have two objects. We add them in the set. You can see here. This is correct. The hash set doesn't allow more than one unique entry. So we have added two entries with different references here, two objects with different references in the memory. And in the hash set, we got only one of them added. We have added the first one. Here you can see the person 1, the person 2 was not added. So we have one entry in it. Okay, you can see person John age 20. But what will happen if I go into the person and I remove this? Okay, we're running the first, we're adding the second person. Okay, and what happened? We have two entries. Is this correct? No, it is not, because they are the same name, same age, and we have two entries in the set, and we expected to have unique entries here, right? So this is a problem, right? It's not cool. So it is very important to implement the hash code. Okay, now it will work correctly. What is the idea here is when you try to put the first object, so how set use this function, and what this function does is the following. When we open the hashing function, you see we pass here name and age, the fields of the class. We open this hash function, which accepts the input arbitrary number of fields by this operator here, and then we are calling the hash code from arrays class and pass those values, in this case h and name, and then this array here, which we have passed, is calculated for each field. We calculate the result here, and this is a hashing function, so the returning type is integer, like you see. So what is happening, really fast, I will show you. what is happening is we pass the our class with the values age and name to the hash function. It's hashing it into some integer. Okay, and give us back this integer. So when we later search for example p1, we will search this element in big O of 1 complexity time, which is constant time, because we know this hash and we know in which bucket the value resides. For example, here are 3 persons. Every person has some hash code. For example, I'll keep it very simple. For example, the first hash code is this, the second is this, and so on. And we have calculated these hash functions when we have added the objects. So when we retrieve them, we know this person 2 is mapped to this hash function, and we will retrieve it in constant time. Okay, how we can assert this? We can go to the add method, okay, to its implementation. Just a second, because hash set, okay. The hash set use the map underneath. Okay, see, here is hash map. Yes, hash set uses the map object underneath. And okay, when we call the map put method, when we put the value here, like you see, we calculate hash for the key. Okay, and here are some checks again, one liner. If the key is null, return 0. If it's not present, calculate it, or return 0. Some checks, but in general we are coming from here, from this set. We are coming here. We call this hash, see here, we call a hash function. We can stop here. Okay, and put it in the book. Very cumbersome. Okay. Okay, this will not happen, but the idea, you got the idea. When we came here for a hash set, we are coming here. So let's set the breakpoint to the first entry. Okay. Now we are in the add method. Okay. And I don't have breakpoints here, but we came here for sure. Right here, put val hash, we hash the value. You got my idea here. here we get some key. A lot of stuff is going on, you see. But yeah, the idea is we get a key, and if we tell P1 hash code, okay, if we do this, we can actually see it. I'll remove this endpoint here because many methods call it and we cannot debug this way. So here is the hash code of P1, okay, 7175 and so on. Okay, we have hash code. When it is called, when we call add, we can double check this. When we call add, see, we call hash code, and object hash generates hash code for us. Okay, and everything is fine. We have just one entry. This is for the hash set, and you have learned something new, I think. Underneath the hash set implementation, there is a map actually there. This detail. If we are using map, it's interesting again. Let the keys let the keys be in strings and person. Okay. So now imagine if we put here, for example, John. Now how the map works, the hash map works. We have unique keys, right? And not unique values. Okay. So let us do this. Let's the person be the key, and the second parameter should be integer. Now we want to put p1 with some description. Sorry, let this be string. And p2 with description too. Okay. Now what is happening here is we will have description too in the end. We can check this. Okay, you can see we add the first entry and the second entry. Again, the hash and the equal method this time is called, and we have one entry in the hash map, the second one, because the value get overridden here because the key is the same. And underneath the hash map, use the uniqueness of the keys. So it's calling hash and equals. Why? Because now I will draw it. Okay, just a second. Okay, let's draw this. Now imagine you have one bucket, one array, many buckets, sorry, one array. this is a hash map. Okay, and here we had a person object, right? A person class from which we create objects. And for example, in every bucket we have map entry. Okay, with key and value. Okay, the key is again calculated via the hash function. Okay, so from the age and name here, we got some int from their values, not the properties. From the values, we get some hash key, for example, this one, and we search the exact person object by this hash function later. When we add it, we calculate this, okay, but we overridden this function here, and it's getting called when we call put on the map. This is the person hash code is getting called, and I mean when we say put, for example, person1, okay, with some value here, description, what is happening is we are going to the hash code method in the person class, okay, and we calculate this hash number. Later, when we try to retrieve, we save this map entry in this bucket, so p1 and the description. P1 is the key, the description is the value. This map entry is object and it's get saved in this bucket, in this array. And later we add another objects, okay, but imagine we have a big number of person objects, and this hash key, it's not guaranteed to be unique. So for example, for person1, this is the hash key, and for person 1999, imagine we have created so much persons, we have for this value we have the same hash code generated. What will happen then is, imagine they are stored here in this bucket, and we have one map entry here already for the person1, and here a linked list will be created for storing the second value, which is, imagine here resides p1 resides here, and we say, hey, put this hash, and we see this hash is already present here in the bucket, and we say, there is a value here, so we will create a linked list and we will store the second value in the linked list, okay. So if there is one more collision, for example, we are continue to creating and storing objects, and we are at percent on this person, and the hash code is again generated the same. We came here, there is a third value of it for person 2000, and this is a linked list here. So imagine now the scenario when we want to get some object. For now, we have called only the hash code of our class, right? But imagine we want to get some persons now. And we try to get this one. And okay, we say get, we pass the key, the object person 2000, and what will happen? We'll see it has this hash code, and then what will happen? The equal method will be called between person 2000 and person 1 for equality. It will call equal will return false, then it will go here, reiterating the linked list. It will compare it with person 99. It will say it is not equal. It will return false from here, and then it will compare it with person 2000, and this will return true, and we will retrieve this object. So see, from the constant time we have come to the not so constant time that it will be big of 3, because we have iterated 3 times before we retrieve our object. So writing good hash function is crucial to avoid those kind of collisions. We can't avoid them always for a big number of entries, but if we write some stupid function, basic function, we will have a lot of collisions and a lot of linked lists. By the way, in after Java 8 and in Java 8, this linked list, if it grows over 5 entries, we have over 5 collisions, it will create a red black tree, if I'm not wrong. I'm not wrong, but this tree, which is another structure, and the values are arranged in a kind of way in which the retrieval is very faster. Because imagine here, this is cool optimization, because if we have 100 collisions, this will be the time for retrieving a single object from the hash map, and with the tree this will be reduced, I think, by 2. So I'm not sure about how the red black tree works exactly, because it's very complicated algorithm. I know it briefly, but nobody will ask you this deeper for this concept, but you can say in an interview, we are creating, when we have collisions, we have the same hash code. We can have the same hash code for object. For example, person 1, person 2, person 3, they can have one hash code, but the equals method will never return true when we search. They will be different. So if they ask you, can two objects have the same hash code, you should say yes. say a different objects, two different objects can have the same hash code, okay? And even three different objects, n number of objects can have a different hash code here. And they ask this on interviews. So, but here the equal method combined with the hash code will guarantee the uniqueness, because it will, like I say, it will start iterate on the same hash code. Imagine these three objects, and the equal method will ask is p2 is equal to p is our px equals p1, is it equal p2, is it equal p3, and one of these will equal our input here. Okay, when we say get, this will happen, this stuff will happen. So the tricky part here is they will ask you, let's revise it, they will ask you why we should use equal method and hash code method, why we should override them, and you should explain all these things to the interviewer, because if you just say we need to implement them, this is not the case. You should know with deep knowledge why you do this exactly. You will say we use the hash code for the set, for example, for the hashing data structures, and for the hash map, and for the hash set. You say if there are collisions, we have same objects with the same hash code, they can ask you, can we have two different objects with the same hash code? And you should say yes, we can, and you can explain this. We have the thing with the bucket here. If we have a collision, we have two entries here. Here is the same hash code. You have P1, P2, okay, and then the equal code will decide which one we want to retrieve by .get from the hash map, okay, from the hash map object. When we say get, this happens. We came to some bucket with the hash code and we start iterating with the equal method. If there is no collisions, we just retrieve this here, this value in the bucket, and we are fine. But this is the tricky part, and I tell you, when you say put, then this calculation come in place. Okay, we calculate the hash code from the values of the fields and we get some integer. It's a little bigger, for example, but for explaining purposes I use 4 digits here. When you use hash set, you're using map put method under the hood. So actually this implementation of hash set, I show you this in the code, have map inside it, and you call map put, okay. And I can show you this again. I will create one hash set here. Now see hash set, and this is the constructor of the hash set, and what it says, we have a instance field here, hash map, see, up here we have a map, and we create a new hash map when we create set. When we call set some objects, when we call add on the set. Oops, sorry, I didn't use the interface here. It's a bad practice. And we go to the implementation part of HashSet. We can see again map put and the value. We put the value and some object, some empty object, okay. And we return true or false. We return true or false. So this is for the equals and hash code. Sorry. For the equals and hash code implementations, why should we use them and what can be asked in an interview and how they work under the hood. Also, we revised the hash map and hash set data structures. So I think this is very important, and this question is asked on all level of the interviews. I mean, for the mid, for the senior, and for the junior level, you can be asked for this. So you should know what's happening under the hood of those implementations. Thank you for your attention, and we'll see in the next video. Bye.